Hey there, this is College Algebra. We're into Chapter 3 now. This first section, 3.1, is on quadratic functions. It's a pretty lengthy section, so we're going to get started. We're going to talk about quadratic functions to recognize that all quadratics have the graph of a parabola, and so we're going to talk about what that means and what that looks like and how to find it. We're going to determine a quadratic's minimum or maximum value, and then we're going to use that information to help us solve max-min problems. Okay, so a basic quadratic function looks like this. F of x equals a times x minus h squared plus k. A can't be 0, okay, but it can be any other real number, positive or negative. This is what we call the standard form of a parabola, of a quadratic, okay? If you have a quadratic in this form, then the parabola that goes with this quadratic function has the vertex, and the vertex is the bottom point of the parabola. So if your parabola looks like this, right, your vertex is this very lowest point here, and if your parabola looks like this, then the vertex is the very top point. Okay, so that's what the vertex is, and that point is h comma k. So if you're in this form, standard form, then you can find the vertex, which is the most important point on your parabola. And the parabola is symmetric about the line that runs straight down the middle, the vertical line that runs right down the middle. This is called the axis of symmetry, runs right down the middle. Here at x equals h, and if a is positive, then you open up, and if a is negative, then you open downward. Okay, so let's look at an example. Here's the steps that we're going to use in our example. If you are wanting to graph a parabola in standard form, then you determine by looking at A whether it opens up or down. Just make a little note to yourself. It opens up, opens down. Read off the vertex. Remember that it's minus h plus k, so the sign here is the opposite and the sign here is the same that you're given. And then you want to find x and y intercepts. You find the x-intercepts by solving f of x equal to 0, and you find the y-intercepts by plugging in 0 for x. And then you plot all those points, and if you need more, then you can plug another point in or whatever, and then connect the dots. Okay? So the example we're going to do is f of x equal to minus the group x minus 1 squared plus 4. So what's playing the role of a? A is this number in front. There's no number there, so this is a negative 1, right, in front. And so a is negative 1. So what does that mean? If a is negative 1, then the parabola opens downward. So I just make a little note over here to myself, upside down parabola. All right. Let's find the vertex. What's the vertex? Well, x minus h. So h is equal to 1 here. Based off of this information, h is equal to 1. And this information, k is equal to 4. And so my vertex then has to be the point 1 comma 4. Okay? Alright, so we've got those two information pieces. Now we're going to find the x-intercepts. We got to solve f of x equals 0. So we're going to plug in x equals 0 here. 0 equals minus x minus 1 squared plus 4. Alright, we're going to solve this by extracting roots, so I'm going to add x minus 1 squared to both sides, and then I'm going to square root both sides. When I do that, remember I get plus or minus. Alright, and so what that means is I get x minus 1 equals the square root of 4 plus or minus, which is 2, and so I add 1 to both sides. I get x equals 1 plus or minus 2. If you add 1 plus 2, you get 3. If you subtract 1 minus 2, you get negative 1. Okay? So you get two x values, and remember those came from when y equals 0, and so the x-intercepts are 3, 0, and negative 1, 0. Okay? So when you solve these, remember that the y part is always 0 for x-intercepts. Okay? For the y-intercept, you're only going to ever have 1, and you're going to get that by plugging in. So if you plug in x equals 0 here, what do you get? F of 0 is negative 0 minus 1 squared plus 4. 0 minus 1 is negative 1, negative 1 squared. You do the negative 1 squared inside the square first. This negative out front doesn't affect it at all yet because of, please excuse my dear Aunt Sally, PEMDAS. We've got to do the exponents before we do the negatives. And so we get negative 1 squared, which is positive 1 with a negative out front. So we get negative 1 plus 4, which is equal to 3. And so the y-intercept is 0, 3. Okay? So summarize all that information. Let's list all the stuff we've found so far. The parabola opens down. The x-intercepts are 3, 0 and negative 1, 0. The y-intercept is 0, 3. And the vertex is 1, 4, which we actually found earlier. So what we're going to do is we're going to plot all those points on a graph. Okay, here's your two intercepts. X-intercepts, negative 1, 0 and 3, 0. Here's your y-intercept, 0, 3. Here is your vertex, 1, 4. And then you know it opens downward, and so you just connect the dots. It doesn't have to be perfect, y'all, but certainly the vertex should be the highest point. You should cut through these intercepts, and you should be pretty clean there. Okay? So that's the process. It takes a little while, but you can methodically work through it. And so here's what I want you to do. I'm going to give you a practice problem here and remind you of what you're supposed to do. So what are you supposed to do? You're supposed to determine opens up or down, right? Then you're supposed to do the vertex. Then you're supposed to do the x-intercepts. And then you're supposed to do the y-intercepts. Okay? And so you might have more than one x-intercept. You might have no x-intercepts. For y-intercepts, you'll always have one. So find all this information and then see if you can sketch the graph. Pause the video and come back and let's see what happens. Okay, so what tells you whether it opens up or down? This number right here is A. A is equal to 2. 2 is greater than 0, and so that means it opens up. So our parabola is going to look something like that. Okay. The vertex is HK. Well, H is the number subtracted from X here. Since it's added, H is equal to negative 1. And then this is a minus as well, so you get minus 8 for your K. X-intercepts, set this equal to 0. 0 equals 2 times X plus 1 all squared minus 8. We're going to take 8 to the other side, add 8 to both sides, and then divide both sides by 2. And those divide away and leave a 1, and so then we end up with 4 equals X plus 1 all squared. Take the square root of both sides, make sure you do plus or minus. Take the square root of X plus 1 squared and get X plus 1. Take the square root of 4, you get plus or minus 2. And then once again, we're going to subtract 1 from both sides. We get negative 1 plus or minus 2 equals X. And so X will be negative 1 minus 2, which is negative 3, and negative 1 plus 2, which is positive 1. So your two x-intercepts then are negative 3, 0, and 1, 0. And then finally for the y-intercept, you're going to plug in f of 0. And so you get 2 times 0 plus 1 squared minus 8. That's 2 times 1 squared minus 8, which is 2 minus 8, which is negative 6. And so we get 0, negative 6. Okay? So what is all the information that we have? We know we open up. We know we have a vertex of negative 1, 8. We have intercepts of negative 3, 0, 1, 0, and 0, negative 6. Negative 1, negative 8 is your vertex. And so we're going to plot those points. You don't have to do the color coding like I did. We're going to plot those points. And so your vertex is negative 1, negative 8 all the way down here at the very bottom. Okay. Your x-intercepts, we're going to do in green, that's negative 3, 0, and positive 1, 0. All right. Your y-intercept is 0, negative 6, right here. Let's start with this guy. Goes up through here. Okay, it doesn't go straight up, obviously, but it's pretty close to straight up by the time you get there. And it goes straight up through there. All right, close enough. And then this guy comes down through there, and it's got to hit the red. All right, it doesn't come to a point, but it's hard to draw it straight and smooth. All right, so we get these points here, maybe make them a little bit bigger. and again, I'm not going to be super picky about these. I do want you to label your points. This is negative 1, negative 8. This is 0, negative 6. This is 1, 0. This is 3, negative 3, 0. And then we're good to go. Okay? So that's the process for graphing a quadratic function if the quadratic function is in the standard form. Now, the process for graphing them in other forms is the same process, except you just have to do slightly different algebra. This version, this is the general form of a parabola, and if you're written in this form, you don't want to have to rewrite it in standard form. It takes a long process of completing the square in general and dividing both sides by a, and it just gets to be ugly. And so what we're going to do is we're going to give you this formula for the vertex. That's the only thing you really can't get out of this that you could in the other one, and that's the formula for the vertex. So what you do for the vertex, h is going to be minus b over 2a, and then k is simply going to be plug in the minus b over 2a to your function and get it back out. So this is the x value, and again, this is not magic. It comes from, if you remember the quadratic formula, you get negative b plus or minus some stuff over 2a. So this is when the square root stuff, the discriminant, is equal to 0 in your quadratic formula, and that only happens once. And so that's where this comes from. And so you make sure you know a is the stuff that's still the same. A plays the same role. B is the number in front of the x. And then you can find x-intercepts by solving equal to 0. You can find y-intercepts by plugging in 0, okay, which gives you c. And then you plot the point. So it's the same process as last time. The only difference is this vertex formula, minus b over 2a for h, and then plug in for k. Okay. So what we're going to do, I want you to pause the video and I want you to go ahead and try it with this one. Alright, so just to make sure where we're at, what's a? A is equal to negative 1, the number in front of the x squared. B is equal to positive 4. C is equal to positive 1. Okay, and remember the vertex, the h value comes from negative b over 2a. Okay, plug in to get the k. So I'm going to let you guys do this, pause the video, and then come back and we'll go through it together. Okay, so what do we have? We have a is equal to negative 1, which is negative, so that opens down, parabola opens down. Minus b over 2a, you plug in minus b, you get minus 4 over 2 times negative 1, and so that's negative 4 over negative 2, and so you get positive 2 for h. To find k, you plug into your function, because that's the y value. And so you plug into your function for x, you get negative 2 squared plus 4 times 2 plus 1. And so that's 2 squared is 4, you get negative 4 plus 8 plus 1, and that's 5. And so your vertex is 2, 5. Okay. It opens down, vertex is 2, 5. To find your intercepts, solve 0 equals negative x squared plus 4x plus 1. That doesn't factor. We're just going to use the quadratic formula, guys. Negative b plus or minus square root of b squared minus 4ac. We already found a and c and b before. Over 2 times negative 1, and so you get negative 4 plus or minus the square root of 20 Right, this is negative 4 squared, or this is 4 squared minus 4 times negative 1, that's plus 4. That's all over negative 2. The square root of 20 is the square root of 4 times 5, and the square root of 4 is 2. And so the same thing here, negative 4 plus or minus 2 square root of 5, all over negative 2. And then factor out a 2 here. And so really we can factor out a negative 2. So if we factor out a negative 2 here, we're left with 2 plus or minus the square root of 5 all over negative 2. When you factor a negative out of plus or minus, it's still just plus or minus, right? And so then the negative 2's divide away. And so x is equal to 2 plus or minus square root of 5, which means my intercepts are 2 plus square root of 5, 0, and 2 minus square root of 5, 0. And those are perfectly good x-intercepts, but the problem is when I go to graph it, I don't have any idea where that is really. I got to plug it in my calculator and get an approximation. So while these are your actual intercepts, and these are the answers if you're asked for x-intercepts, when you go to plot them on your graph, you want to know what their approximate values are. And so the x-intercepts are approximately negative 0.2 from here, 0, and 4.2, 0 from here. Okay? So quadratic formula, that's stuff you should be comfortable with, right? Compute the y-intercept. So you just plug it in and you just get c. So f of 0 is minus 0 squared plus 4 times 0 plus 1. And so you get 0, 1 as your y-intercept. And then the summary here, everything that you've got, the x-intercepts are approximately negative 0.2 and 4.2. The y-intercept is 0, 1. The vertex is 2, 5. And the axis of symmetry is x equal 2. All right, we've talked about that earlier. I didn't ask you to find it, but it's certainly helpful. Okay, and so you don't have to graph that axis of symmetry. You don't need that on there. But you can see the x-intercepts are in red. Here the y-intercept is 0, 1. The vertex is up here at 2, 5. And again, my preference is that you actually label these points. You should label these as 2 plus square root of 5, 0, and 2 minus square root of 5, 0. All right. So there's that. All right. If you want to find maxes and mins for your quadratic functions, they're going to happen at the vertex. The vertex happens at negative b over 2a. If a is equal to 0, then you have a bottom value because you open up. So that minimum value happens at negative b over 2a, and the value is the k, plug it in, f of negative b over 2a. If a is negative, then you open downward, which means your vertex is now a max value. And that happens at the same point. Okay. So, in each case, the vertex, when x equals negative b over 2a, gives you the location of the minimum or maximum value. Obviously, if you're not in general form, if you're in standard form, then you just find hk right off of it, right? But we're talking about usually they're given to us in the general form. So for example, the function 4x squared minus 16x plus 1,000, okay? A is equal to 4, so you open up because you're positive, so the function has a minimum value. All right, how do we find what that value is? All right, well, I want you to try it. Give it a shot. Hit pause on the video and find the, we've already determined, right? It is a minimum value. So find the minimum value and determine where it occurs. Hit pause and give that a shot. Okay, so x is equal to minus b over 2a. So that's equal to negative minus 16 over 2 times 4. So that's 16 over 8, which is 2. And now plug that in. F of 2 is equal to 4 times 2 squared minus 16 times 2 plus 1,000. And 4 times 2 squared is 4, that's 16 minus 32 plus 1,000. That's 984. All right. So the minimum value of your function is 984. This value occurs when x equals 2. So x equal 2 is the x value and 984 is the y value. Alright? Now we can use this process to help us to solve word problems that are dealing with quadratic models. And so in a quadratic model, you want to read the problem, obviously, decide whether you're going to find a max or a min first thing based on the problem. You want to find if you're going to find a max or a min. Then you want to use the conditions to express the quantity of the function in one variable. So this function is what you're going to maximize or minimize. This is usually called your primary function. And then what's going to happen is you're going to have a secondary relationship, but it's going to be an equation. Okay, so this is a function, which means it can change values, and this is an equation, which means that it's a fixed value. And that's how you kind of know what's going on. And then you rewrite it in this form, unless it's in standard form where you can read the vertex right off of it. Okay, and then you find the negative b over 2a, or you find the hk value, and then you answer the question. Because it is a word problem, you got to find a word answer. So let's walk through one together. You have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the area that maximize the enclosed area. What's the maximum area? So what are we finding? We're finding the max area. So we're not minimizing, right? We're maximizing. And so we're maximizing area. How do you find area? Well, draw a picture. We got a rectangular region. I don't know how long it is. I don't know how wide it is. So we'll call one side x and one side y. So the area is x times y. Okay, so this is our function, but it's got two variables in it, right? X and y. So the next step is to figure out how to get rid of one of those variables. You have 120 feet of fence. If you're trying to maximize the area, you're going to use all the fence. And so what does your fencing look like? Again, you're going to go around in a rectangle. If this side's x and this side's y, then this side's x and this side's y. And so you have 120 feet of fence that are 2x plus 2y. Right? And you want to get rid of one of your variables. So we're going to get rid of y by solving this for y. Subtract 2x from both sides. Divide everything by 2. And you get 60 minus x equals y. And so you can plug that in here, and you get a equals x times 60 minus x. And so now we're going to write it as an actual function of x. A of x, that's not a times x, right? That's a of x. And FOIL this out. You get 60x minus x squared. And so if you want to be able to use the methods we've been using, you've got to write it in standard form. And so standard form is negative x squared plus 60x. Right? So we've got negative x squared plus 68x. Calculate negative b over 2a. You get negative 60 over 2 times negative 1, and so that's a positive 30. And now if you want to find out what that is, that has to be your maximum. And so you do f of 30, which is negative 30 squared plus 60 times 30. And so that gives you negative 900 plus 1800, which is 900 square feet. To answer your question, you've got to figure out the other dimension, right? You were told that y is equal to 60 minus x, so plug that in and you get 30 feet. And so the rectangle that gives you the maximum area is 30 by 30. And we just calculated the maximum area, and that was 900. So the maximum area is 900 square feet. So both of these answer you had two questions posed. Both of these answer the questions you were asked. The dimensions, 30 by 30, and the maximum area is 900. So take a look at that stuff and play around with those, and let me know if you have any questions. Thanks.